Then comes the visceral pleura. The parietal pleura and visceral pleura, they are to making a sac-like structure which is known as pleural sac. That this when a drawing of the spring done by the central common from the headquarter brain, from the auricular rootlets, what happens? They create a negative pressure inside the intrapleural cavity. Because lung is adherent to this visceral pleura, this negative pressure transmitted to the attached alveolar sacs around the total visceral cavity. This has been transferred to the alveolar sacs, the inside cavity. That means a negative pressure is created inside the alveoli. But nature doesn't allow this negative pressure to be maintained, so air goes into the area via nostrils and trachea and everything downstream to the alveoli. This is the foundation of any ventilatory capacity. So now think about the what I have said up till now. Is a mechanical ventilation. We were allowing some air from transfer from machine to the patient. How it goes? With a positive force. Maybe volume or anything, ultimately a force transfer from machine to the patient. And these are all positive pressures. So it is known as intermittent positive pressure ventilation. Basically the entire ventilator technology is a single terminology, this IPVV, intermittent positive pressure ventilation. Now compare with this, just now I have said about the normal mechanics of respiration. Is it corroborating with that? No, not at all. Because in normal respiration, inspiration starts with a negative pressure. But in IPVV, inspiration starts with positive pressure. So it is against of physiology. Against of physiology. What will happen now? We will have a tremendous deleterious effect on CVS, cardiovascular. Basically, the return of blood to the heart, because this respiratory mechanism will act as a third heart for input to the heart, and ultimately it will determine the stroke volume. So, when you are putting a patient on ventilator in IPVV, mind that you are jeopardizing the normal mechanism, and that means the third heart you are cutting. So cardiac output will fall. Sick. Lot of chain reaction has started with this mechanical ventilation. So it is absolutely unphysiological. What we are doing in the intensive care, that is a detrimental to the health. But the entire technology has started from an old fashion, because the earlier scientists, they are more methodical. Before this IPVV, actually this negative pressure ventilator came into the pulse thing. Namaste ji. आइए बताइए. आप लोग देखते इतना सीनियर आदमी आके बैठ गया इधर, हम तो अभी कुछ नहीं बोल सकेंगे. मेरा पान लाया है ना. हाँ ठीक है. निकला लेते हैं. They are very senior from Ranchi, RIMS, on HOD and Director General of the RIMS Hospital. Now I am telling about the negative pressure. So the classically, if you want to ventilate scientifically, you have to have negative pressure ventilator. But nowadays we don't do at all. But our technology starts from this. When I will tell about the history of the ventilator technology, then we will see the pictures. Before that, we will have a debrief now. बोलो तो कैसे बोलेगा दरकार ছিল না সার্কিট থেকে তো গল্প নিয়ে এবার তো আবার গল্প নিয়ে go into the details. This is just beginning. क्या सुबह करंट वरंट नहीं था कैसा है? 2 मिनट पहले ठीक है. जाना था कि बूस्टर हॉस्पिटल बोल रहे हैं. मैं बोला जो साइन करना इधर ले आएगा. मैं नहीं जाऊँगा. पीछे दिया है. चाय तो पिएंगे. बच्चे लोग प्रोग्राम क्या है बता दीजिए. उनको अवेलेबल होना है. हाँ ये तो शाम तक हैंडल चलेगा. आप लंच यूज करके फिर जाइए.
वो एलर्जी है तो सीएपी है 10 महीने से 11 बजे के बाद तुम जान भेंट होगा दूसरे दिन तुम्हारे चक्रवर्ती वाले हो ये चक्रवर्ती वाले ये चक्रवर्ती वाले काय बजे आले
क्या सोमवार के लिए काम करते हैं
हेलो और साथ
Hello, good morning. Please join. মাইকটা কাজ করছে না রে রমন এই রমন মাইকটা
I audible now? Now, you have already learned about the positive pressure ventilation and negative pressure ventilation. I will not say anything about the negative pressure ventilation, only I am showing this historical picture, origin of mechanical ventilation, because it is a very famous historical slide. The era of intensive care medicine began with the positive pressure ventilation when, see, at 1955 at Mass General Hospital. And before that, all were restricted to the negative pressure ventilation. That means the scientific ventilation started first, then we pass on to this unscientific ventilation from 1955. These are the pictures of the positive pressure ventilation. This is the trolley where patient lies and the head comes out of this thing. That means there is a jacket, whole body inside this machine, and a negative and positive pressure is applied around the chest wall, just like an artificial respiration we are giving in Holzer-Nelson method or Sylvester's method. There are plenty of artificial respiration method. See, this is a polio ward. How many ventilators are used during the polio epidemic in Europe? We have seen. I am not going into the details of this, but till date this is accepted as the most scientific. Of course, nowadays again it is coming up in the market in a different variety. Now again go back to the IPVV, because we are in an era of IPVV and unscientific ventilation. The basic characteristics of mechanical ventilators. Now your workshop starts from here. Any ventilator is nothing but a machine. It requires some power. So starts from the power source, how it operates. Already I have told about the analogy of the steam engine and everything. Power source or input power can be electrical or pneumatic or combination of both. So ventilators, according to the manufacturer, that may be purely electrical. It doesn't require any gas source. The gas is generated within the machine by an electricity. Then pneumatic. These machines are classically made on the analogy of the steam engine. The machine requires only compressed gas, nothing else. No electricity, no battery is required. So these are the two classical examples of electrical and pneumatic ventilators. But nowadays, most of the sophisticated ventilators are made of combining electrical and pneumatic both. Because already on the master picture you have learned about few things about the sensors, photo sensor, flow sensors and all these things. They pick up lot of data from the sensors, and that has to be modulated according to the demand of the patient. So it requires a computer inbuilt, so it requires an electricity, whether it is a pneumatic or non-pneumatic. The one pneumatically driven and electronically controlled. Nowadays, 90% of the ICU ventilators are made of performance technology. The pneumatically driven, electronically controlled. The basic mechanism flip-flopping done by pneumatics and control done by electronics. Then comes how it works. The internal control system, which in turn has 5 components. Any ventilator in the world, they have to have these 5 components. I will go one by one. Before that, I will show you some pictures of drive mechanisms. See, this is a classical cylinder. This is a rotary wheel. It is rotated by a pneumatic motor or by electrical motor. The flywheel moves with a crankshaft. A piston is attached. Piston goes in and out, and air goes into the system. This is the bag-in bottle arrangement or directly to the patient. The patient is ventilated just like a Aaron Smith's hopper. Then another variety is spring loaded or weighted. There is a weight inside over the thing and spring inside. So counteracting the forces of the spring and the weight, the ventilator operates. Another thing, blower operated. See, there is a blower. Blower means all of you have seen blower in your domestic appliances. That is a vacuum cleaner. Any vacuum cleaner is an analogy of a blower ventilator. It has got a blower, it rotates in a very high speed and it draws air from the one end and another end, the air goes out. Now, this is the continuous stream of air. Now, if you can chop this air with an obstruction, then a seesaw movement of air will create and that is transferred to the patient. That is a blower operated ventilator. How the drive mechanism works is the piston driven. There are two types of piston. One is a rotary, what already you have seen. There is a rotary wheel, a cam is attached, the piston goes in and out. And another is a linear drive. This is a crankshaft, the gear will move here and it goes like this and it moves. So linearity is maintained. These are the basic things. Then the spring loading. There is a bellow concept in the back. Inside that there is a spring countered into the air force and the spring tension. The lung is inflated. I am not going into the details because I don't have time to go into the details of all these things. These are the motor driven. There is a motor. Here the blower pushes some air and there is a concept in the back. It pushes the concept in the back so the air goes out through this valve to the patient. There is an exhalation, inspiration and there is an exhalation. Now comes to the high-end valve management. This is a combined power mechanism because nowadays most of the ventilators they use the this combination of the powers. Here you have seen it is not actually the generation of the air. Up till now what you have seen, piston and all these things, spring loaded drive, concertina bag, all these are on the basis of the generation. But this drive mechanism is completely dependent on some other source of pneumatic. Means some compressed air has to be delivered to this valve from the compressor or from the cylinder. It goes into this type of valve. This valve has got a magnet inside. It is a coil and two wires are connected. When the magnets are energized, the valve opens and when it is demagnetized, valve closes. So it creates an opening and closing of the gates. That means it's opening of closing of the inspiratory or expiratory valve is done by this proportional solenoid valve mechanism. This is the highest quality, that is a microprocessor control. This is just like an MPFI car in now most of the cars in India, BS2 specification, after BS2 specification, most of the cars they use the MPFI technology. No use of spark plug or any carburetor or this carburetor combination. They inject fuel into the different cylinder and it is been combusted. Like that, it has got solenoids inside which opens in series and lot of variations of air quality can be done at the output. So most of the nowadays ventilators, they use this microprocessor control on valves. This is all proportional solenoid valves variety. Forget about the technology, this is not an engineering class, I am not going into the details. So I am deliberately not going into the details of operational side. But the basic operational, now I will tell about how a machine works. That means that the 5 components. The internal components have the control system, mechanical drive mechanism, control panel, output control valves and pneumatic circuits. These are the common to all the ventilators. Now coming one by one. The control system. This might be an open loop, unintelligent system or closed loop intelligent system. Already you have learned about it during the master diagram. I have told you there is 2 limb circuits. That means air goes into the patient lung by one limb, that is inspiratory limb, and other limb, expiratory limb. It goes inside the machine where the exhalation ports and it has been monitored from that. That means some form of feedback is fed to the machine ROM and RAM for combining a generation of flow pattern. These type of machines are closed loop. That means they can able to handle the data gathered from the sensor. And unintelligent is a low pulse ventilator, has only one loop. One limb has got an opening and closing valve without any monitoring devices. But this is also available because our country is cheap country, we are using the cheaper ventilators also. But only I am highlighting this, most of the ventilators, how the data acquisition is being done. It is a 500 times per second. So it's a very fast rate. Nowadays, most of the ventilators which is kept here, they pick up data 32,000 times per second. That means one breathing cycle is split up into small components. And that signals are being plotted inside the RAM, and that is handled by the computers. Because of digitization, it is possible. Now, mechanical drive mechanism. A variety of devices are used in various ventilators, including the spring-loaded.